Forget the Sunday school stories you grew up with. Forget the stained glass windows and the peaceful hymns about the Holy Land. The reality on the ground is entirely different. You are looking at the most dangerous, volatile, and heavily contested real estate investment in human history. Let us look at the raw numbers. Over $100 billion in United States military and economic aid has poured into this exact soil over the decades. It is a place that has endured over 4,000 years of continuous siege, destruction, and brutal rebuilding. Yet this entire piece of land is smaller than the state of New Jersey. Despite its microscopic footprint on the world map, what happens on this tiny strip of desert dictates global oil prices, drives American foreign policy, and can trigger international military mobilization in the blink of an eye. It is a fortress held together by iron high-strength concrete and the most cutting-edge defense technology on the planet. The people living here do not just survive the harsh environment and constant threat. They engineer their way out of it. Every inch of dirt here has a calculated price paid in both blood and heavy machinery. My team and I did not come here for a pilgrimage. We are not here to walk in the footsteps of ancient prophets or admire the religious architecture. We are here to look at the gears of a machine that has been grinding for millennia. We want to tear off the ancient facade and see exactly how humans survive, build, and fight in a place where the standard rules of economics, military logistics, and daily survival no longer apply. Imagine standing on a busy street corner in one of the most densely populated coastal strips on Earth. Above ground, you see apartment blocks, narrow alleys, and crowded markets. But beneath your feet, hidden from the drones and the satellites, is an entirely different world. It is a subterranean labyrinth that military strategists simply call the Metro. We are talking about over 300 miles of interconnected tunnels. To put that into perspective, that is a network larger than the entire London Underground, built entirely in secret under a territory that is completely blockaded by land, air, and sea. The first question any engineer or logistics expert asks is how you physically build a project of this massive scale without getting caught. The math is staggering. You cannot just order thousands of tons of steel and cement. Every bag of concrete that enters this territory is strictly monitored by the surrounding military forces. To build the metro, materials meant for civilian hospitals and residential housing were systematically diverted underground over the course of more than a decade. Digging through loose coastal sand is incredibly dangerous work. If you do not reinforce the ceiling immediately, the sand collapses and buries the digging crews alive. So the engineers developed a system of prefabricated concrete arches. These arches were cast in secret workshops above ground and then lowered into the earth piece by piece to create structurally sound corridors capable of withstanding the immense vibrations of heavy bombs dropping on the surface. This is not a primitive series of dirt caves. This is a highly calculated tactical reality. Down there, you will find heavy-duty ventilation systems pumping fresh oxygen from hidden surface vents so the fighters do not suffocate deep underground. You will find miles of electrical wiring powering lights and secure communication lines. But the true genius of this engineering lies in what the military calls the spider hole strategy. The tunnel network is specifically designed to neutralize the overwhelming air superiority of a modern high-tech military. A fighter can use a trap door hidden under a kitchen floor, a mosque, or a sandbox. They pop out fire, a shoulder-mounted rocket, at an advancing armored column and slide back underground within 15 seconds. By the time the retaliation strike hits the target, the fighter is already half a mile away, walking safely through a lit corridor 100 feet below the impact zone. They are fighting ghosts. But fighting underground completely strips away the advantages of modern technology. If you take a sophisticated military-grade GPS tracker down into the metro, it becomes an expensive piece of useless plastic. Standard global positioning systems rely on high-frequency radio waves transmitting from satellites orbiting thousands of miles above the Earth. Those signals are relatively weak. The moment you descend past 10 or 20 feet of solid earth and thick, reinforced concrete, the signal is entirely absorbed and blocked. Down there at 100 feet below the surface, a billion-dollar satellite network cannot help you. Navigation reverts to old-school World War II methods. You move by dead reckoning, using physical compasses, pacing distances, and relying on hardwired field telephones that cannot be jammed or intercepted by enemy signals intelligence. It completely rewrites the rules of modern combat. The military force above ground is forced to fight a three-dimensional battle against an enemy they cannot track. Every patch of dirt, every basement, and every empty field becomes a potential ambush point. The sand itself has been weaponized through brute force, engineering patience, and an endless supply of diverted concrete. Walk through the crowded streets of the old city today, and you are surrounded by the noise of markets and the weight of modern stone buildings. But directly beneath your boots is an entirely different frontier. It is a subterranean construction zone that defies conventional civil engineering. My team went down into the Western Wall tunnels to see exactly how you excavate a 2,000-year-old structure while a fully populated modern city sits resting on top of it. You cannot just bring in a diesel excavator and start digging. One wrong move, and the ancient vaulted ceilings holding up the residential quarters above could collapse like a house of cards. The excavation of these tunnels was a masterclass in slow, methodical stabilization. To clear the length of the ancient Temple Mount, retaining wall engineers had to dig by hand. Every foot of dirt they removed had to be immediately replaced with modern steel supports and poured concrete to hold up the weight of the city above. They were effectively building a bridge underneath an existing bridge in the dark. As they pushed further north along the wall, clearing out centuries of accumulated rubble and old water cisterns, they uncovered the raw foundation of King Herod the Great's massive expansion project. And that is where they found the anomaly. Engineers refer to it simply as the Western Stone. It is a single massive block of carved limestone built right into the foundation of the retaining wall. The dimensions are almost impossible to comprehend until you are standing right next to it. It is 44 feet long and about 10 feet high. Based on its depth, ground penetrating radar estimates its weight at over 570 tons. Let that number sink in. That is a single piece of solid rock that weighs more than 2 fully loaded Boeing 747 commercial passenger jets. So the immediate question every construction professional asks is, how on earth did they move it? This was built in the 1st century before Christ. They did not have hydraulic jacks, diesel-powered crawler cranes, or multi-ton flatbed trucks. The methods they used represent the absolute peak of ancient mechanical engineering. To understand this, we look at the writings of the famous Roman architect and engineer Vitruvius, who documented the heavy lifting technology of the era. Vitruvius described massive wooden treadwheel cranes. These were operated by teams of men walking continuously inside a giant wheel to drive complex block and tackle pulley systems. By using specific gear ratios, these wooden machines could lift incredibly heavy loads. But even a fleet of Roman cranes could not lift 570 tons. For a block this size, brute vertical lifting was completely off the table. Instead, the ancient engineers had to use the physics of the earth itself. The stone was quarried slightly higher up on the mountain. To move it, they carved a highly calculated trench acting as a rail system. They laid down massive wooden rollers, or possibly iron spheres, to act as heavy-duty ball bearings. Using an army of thousands of oxen pulling massive hemp ropes, they slowly guided this monolith down a solid compacted earth ramp. The leverage had to be mathematically perfect. A shift of even a few degrees could snap the thickest ropes and crush hundreds of workers in seconds. They did not just move it down the mountain. They placed it into the wall with such staggering precision that you cannot fit a razor blade between the seams of the adjoining stones today. And they did it all without a single drop of mortar. The sheer gravitational weight of the stone itself is what locks the entire foundation into place to withstand earthquakes and military bombardments over the centuries. When you look at the scale of the Western stone, the timeline of human engineering gets turned completely upside down. We like to think of ourselves as the ultimate masters of heavy construction. But walking through these reinforced tunnels, looking at what was achieved 2 millennia ago with wood rope and pure mechanical genius, it is hard not to feel completely humbled. If you look at early 20th century history, the original kibbutz was a hardcore socialist experiment. A group of pioneers went into the harsh desert to farm the land, and they shared absolutely everything. Nobody had private bank accounts. Nobody owned their own tractor, or even their own clothes. But pure socialism rarely survives contact with human nature and modern economics. By the 1980s, the traditional kibbutz model was collapsing under massive debt. They had to adapt or go bankrupt. And they chose to adapt in a way that completely transformed the global agricultural industry. They privatized their operations and turned these isolated farming communes into high-tech industrial hubs. We visited a kibbutz that now produces 10% of the drip irrigation tech used around the globe. It is not just farming anymore. It is precision fluid dynamics and advanced manufacturing. They design and build heavy-duty polymer valves, automated water pressure systems, and intricate underground sensor grids. These systems are now exported to massive commercial farms across the American Midwest to maximize crop yields in drought conditions. The people living in these communities today are no longer just picking oranges by hand. They are software developers, mechanical engineers, and international logistics managers operating global supply chains out of a desert outpost. But doing business in this region comes with a very specific set of geographical hazards. Many of these highly profitable tech hubs are located literally 2 miles from a hostile border fence. When you live and work that close to the wire, you are entirely within range of short-distance mortar fire and unguided rockets. You do not have the 15 seconds of warning that people in the big cities get from the Iron Dome radar. You have maybe 3 to 5 seconds. Because of that brutal physical reality, the architecture of every single home in the kibbutz is dictated by strict military engineering codes. Since 1992, the law requires every new residential building to include a specialized safe room. This is not a dark storm cellar down in a dirt basement. It is a reinforced, secure chamber built directly into the everyday living space of the house. Most families use it as a bedroom for their children or a home office. But the engineering hidden behind the drywall is heavy duty. The walls, floors, and ceilings are poured with solid reinforced concrete that is specifically formulated to withstand the immense blast wave of a direct artillery impact. The window is made of thick, bullet-resistant glass, shielded by a heavy sliding steel plate that locks directly into the concrete frame to prevent shrapnel penetration. The door alone is a piece of serious hardware. It weighs hundreds of pounds. It is a solid steel blast door mounted on heavy-duty industrial hinges that seals completely airtight when the heavy latch is thrown. They even build military-grade air filtration systems directly into the ventilation ducts of these bedrooms. If there is a chemical or biological threat, the room can be mechanically pressurized to keep toxic gas from seeping under the doorframe. It is a staggering contrast to witness. You have brilliant engineers designing billion-dollar agricultural technology on their laptops, while their children sleep safely inside what is essentially a military bunker. It is the ultimate collision of high-end economic innovation and raw frontline survival. June 5th, 1967. It is a morning that completely rewrote the manual on modern aerial combat. Military academies across the world still study Operation Focus today. The strategy was entirely counterintuitive. You do not win a war by waiting for the enemy to strike first. You win by neutralizing the threat while it is still sitting on the tarmac. At exactly 7:45 in the morning, nearly the entire Israeli Air Force, consisting of about 200 fighter jets, flew out over the Mediterranean Sea. The timing was not a random choice. 7:45 was the exact moment the Egyptian morning air patrols returned to base, and the pilots went to the mess hall to eat breakfast. The Israeli jets were flying barely 50 feet above the water. At that extreme low altitude, they were completely invisible to Egyptian and Soviet-built radar screens. They maintained absolute radio silence. No talking, no electronic signals, just pure, calculated, dead reckoning navigation. When they finally pulled up over the Egyptian air bases, the element of surprise was absolute. But the Israeli pilots did not just shoot at the parked planes. That is a civilian misconception. First, they dropped specialized runway penetration bombs directly onto the concrete landing strips. These weapons used rocket boosters to drive themselves deep into the tarmac before detonating, creating massive, impassable craters. Once the runways were destroyed, the surviving enemy fighter jets were completely trapped on the ground. They could not take off. In less than 3 hours, the air superiority of 3 nations was systematically wiped out. The war was effectively decided before the heavy ground troops even fired a single shot. With the skies completely cleared, the ground offensive mobilized. In my view, the tank battles in the Sinai remain the absolute peak of 20th century armored warfare. We are talking about thousands of tons of steel maneuvering across an open desert that offers absolutely no natural cover. It was a brutal high-speed chess match fought with heavy caliber cannons. The logistics of moving that much heavy armor, keeping the massive diesel engines running in 110-degree heat, and coordinating fuel supply lines across shifting sands is an engineering nightmare. Inside those tanks, the temperature easily reached 130 degrees. The tank commanders had to operate with their top hatches open, covered in blowing sand and toxic diesel exhaust, just to maintain visual situational awareness. It was mechanized warfare stripped down to its most raw, violent, and unforgiving elements. But the Sinai Desert was just one front of this war. If you want to understand the true strategic currency of the Middle East, you have to look north to the Golan Heights. In this specific part of the world, high ground is not just a tactical advantage. It is the only currency that actually matters. The Golan is a massive volcanic plateau that looks directly down into the northern Israeli valleys. Before 1967, the Syrian military spent over a decade engineering an impenetrable fortress into this rock. They did not just dig shallow dirt trenches, they poured thousands of tons of heavily reinforced concrete to build deep subterranean bunker networks. These artillery positions were practically immune to standard aerial bombing. My team walked through several of these abandoned Syrian bunkers. The military engineering is genuinely intimidating. They featured staggered zigzag entrances specifically designed to deflect the blast waves of incoming artillery shells. They had heavy steel blast doors and overlapping fields of machine gun fire built right into the solid basalt rock. To take these heights, Israeli infantry and armor had to fight an agonizing uphill battle against heavily fortified positions. They were essentially driving their modified Sherman and British-built Centurion tanks straight up a steep rocky incline directly into the teeth of heavy artillery and anti-tank fire. Every single inch of that volcanic plateau was paid for in blood and shattered tank tracks. Taking that high ground required a level of close-quarters tactical coordination and sheer human endurance that most modern military analysts still find hard to fully comprehend today. The scars of that engineering and those armor battles are still resting in the sun right now. Take a look at the computer or smartphone you are using right now. There is a very high probability that the microchip powering that device was designed in a narrow strip of land along the Mediterranean Sea. They call it Silicon Wadi. It is the Middle Eastern answer to Silicon Valley, but the foundation of this tech hub is entirely different from what you see in California. In the United States, the typical tech billionaire drops out of a prestigious university to build a software application in a suburban garage. In Tel Aviv, the pipeline to the global tech industry runs directly through the military. At age 18, mandatory military service kicks in for the population. The physical heavy hitters go to the infantry or the armored divisions. But the absolute top-tier mathematical minds are heavily screened and recruited into a secretive intelligence division known as Unit 8200. This is the equivalent of the American National Security Agency. These teenagers are not handed rifles. They are handed supercomputers and tasked with intercepting encrypted communications, breaking complex algorithms, and conducting offensive cyber warfare against hostile states. They operate under immense psychological pressure. If a 19-year-old coder makes a mistake in Unit 8200, intelligence is lost and people can die. When these kids finish their military service and enter the civilian workforce at age 22, they are not looking for entry-level corporate internships. They take that intense, high-stakes problem-solving experience and immediately launch cybersecurity and hardware startups. When you have spent 3 years hunting hostile actors on the dark web, pitching a business plan to a venture capitalist in a boardroom is completely effortless. This aggressive military-to-civilian pipeline is exactly why major technology corporations like Intel, Microsoft, and Google have established massive research and development headquarters in Israel. Intel alone operates massive fabrication plants right in the middle of the desert, producing the silicon wafers that power global commerce. They want direct access to that combat-tested talent pool. But the true capability of this workforce goes far beyond consumer electronics and civilian software. It extends into the absolute darkest corners of modern warfare. To understand the sheer power of this engineering mindset, you have to look at the legacy of the Stuxnet computer worm. Around 2010, the world woke up to a completely new reality of combat. Intelligence agencies needed to stop a hostile underground nuclear program from enriching uranium. Sending in fighter jets to bomb the deep underground facility would have triggered a massive regional war and cost billions. So instead of dropping a 2,000-pound bunker buster bomb, they dropped a few lines of computer code. The Stuxnet virus was an absolute marvel of digital engineering. It was allegedly introduced into the highly secure offline nuclear facility on a simple thumb drive. Once inside the system, the code did not just steal data. It actively hunted for the specific programmable logic controllers that operated the massive industrial centrifuges. Stuxnet silently ordered the heavy centrifuges to spin out of control at speeds that physically tore the metal machines apart, while simultaneously feeding false safety readings to the human operators sitting in the control room. The engineers on duty thought everything was running perfectly normally, while their multi-billion-dollar facility was literally ripping itself to pieces. Our team looked at the technical aftermath of this operation, and the conclusion is chilling. That single piece of software caused more physical destruction to a heavily fortified nuclear program than 1,000 conventional military bombs could have ever achieved. It completely redefined global military strategy. Today, the most dangerous weapons are not rolling off an assembly line. They are written in air-conditioned rooms in Tel Aviv by kids who can shut down an entire national power grid from thousands of miles away. Under strict Orthodox law, you cannot operate electrical circuits on the Sabbath. The ancient texts forbid lighting a fire, and modern religious authorities interpret closing an electrical contact as the exact same thing. For an entire day, a massive portion of the population powers down. But how do you live in a 30-story high-rise building or run a modern hospital without flipping a single switch? You do not abandon the technology. You engineer a mechanical workaround. Imagine standing in the lobby of a high-rise in Jerusalem on a Saturday morning. You cannot press the call button for the elevator. Once inside, you cannot press the button for your floor. Doing so closes a circuit and breaks the religious law. The solution is the Shabbat elevator. Right before sundown on Friday, the building computer takes over the system. The elevator enters a continuous automated loop. It travels up and down the shaft, automatically stopping at every single floor. The doors open mechanically, stay open for a calculated number of seconds, and then close. It is incredibly slow and burns a massive amount of electricity, but it completely bypasses the human action of completing a circuit. This specialized engineering extends directly into the kitchen and even into military logistics. If you cannot turn an oven on or off, how do you eat a hot meal? Appliance manufacturers design ovens with specialized microchips. When switched into Shabbat mode, the oven disables all digital displays, interior lights, and safety shutoff features. It maintains a constant low heat regulated by an internal automated thermostat that the user never interacts with. For emergency medical personnel and military units who absolutely must communicate on the Sabbath, engineers have designed specialized phones. These devices use indirect mechanisms. When a medic presses a button to answer an emergency call, they are not actually closing an active circuit. They are removing a physical blocker that allows a continuously running optical beam to register a command. It is a highly complex analog loophole built into a digital device. But the most fascinating example of this problem-solving is something known as the Shabbat lamp. It looks like a standard heavy-duty bedside reading light, but it solves a very specific human problem. You want to read in bed, but you cannot switch the lamp off when you are ready to sleep. Instead of wiring a standard electrical switch, the engineers built a heavy mechanical shield. The light bulb stays on continuously inside an insulated heat-resistant cylinder. When you are done reading, you physically slide a solid rotating cover over the bulb. You have not broken the electrical current. You have simply trapped the light inside a box using raw mechanical force. It is a completely unique sector of the global manufacturing industry. You have some of the sharpest engineering minds on the planet, dedicating thousands of hours of research and development not to invent a new weapon or a faster computer. They are engineering complex mechanical systems specifically designed to mathematically bypass the rules of ancient scripture. Drive down to the lowest point on the surface of the Earth, and you will not find a peaceful, natural spa. You will find a massive, highly aggressive industrial mining operation. People travel from all over the world to float in the Dead Sea. But the reality is that this body of water is essentially a giant chemical extraction factory. The water here is densely packed with potash, magnesium, and bromine. These are the critical chemical components that keep global agriculture alive and power modern metallurgy. To extract these minerals, heavy industrial plants pump millions of gallons of water out of the deeper northern basin and channel it into shallow artificial evaporation pools in the south. They let the brutal desert sun boil the water away. What is left behind are massive mountains of highly profitable salt and chemicals harvested by fleets of heavy bulldozers driving directly on the salt crust. But this aggressive resource extraction comes with a staggering physical cost. The Dead Sea is currently dropping by over 3 feet every single year. Let that massive number sink in. 3 feet of vertical water loss annually. The shoreline you stood on a decade ago is now a dry, barren crust of salt baking in the sun, miles away from the current water edge. This extreme drop is happening because the water from the Jordan River, which historically fed the sea, has been completely diverted for drinking water and commercial agriculture by the surrounding nations. When you combine that total lack of incoming fresh water with the massive industrial evaporation operations, the sea is quite literally vanishing in real time. This rapid shrinking has triggered a terrifying engineering nightmare along the coastline. As the heavy salt water retreats, it leaves behind thick structural layers of solid salt buried deep under the coastal mud. Fresh groundwater from the surrounding mountains then rushes in to fill the void. This fresh water eats away at the buried salt deposits, dissolving them completely and leaving massive hollow underground caverns. From the surface, the landscape looks totally normal, but the ground you are walking on or driving over is nothing but a thin, fragile shell of dirt resting over an empty abyss. Eventually, the weight of the earth or a passing commercial transport truck causes the shell to snap. The result is a catastrophic geological sinkhole. Thousands of these massive craters, some dropping down over 100 feet, have suddenly ripped open along the coastline. They have completely swallowed entire agricultural fields, paved parking lots, and multi-million-dollar tourist infrastructure. Highway 90 is the primary arterial road running north to south along the sea. Civil engineers have had to repeatedly abandon and rebuild entire sections of this major highway because the ground is literally collapsing beneath the heavy asphalt. It is a brutal example of nature violently reacting to heavy human interference. You cannot simply drain a massive sea and expect the surrounding geological foundation to remain stable. The extreme nature of this water also creates a very unique physical reality for the human body. The salinity of the Dead Sea sits at roughly 34%. That is nearly 10 times saltier than the open ocean. Because of this extreme salt concentration, the water is incredibly dense. It feels thick, almost oily to the touch. It completely alters the physics of human buoyancy. You physically cannot sink. If you wade into the water and pick your feet up, the dense liquid violently forces your body to the surface. You pop up and float like a cork. You cannot drown in the traditional sense of slipping beneath the surface and sinking to the bottom. But it is highly dangerous. If you lose your balance and flip face down, it is incredibly difficult to force your legs back under you against that heavy buoyancy. The water is so toxic to human biology that swallowing even a few ounces causes immediate chemical burns in your throat and can trigger sudden organ failure. It is a harsh, unforgiving environment where heavy global industry failing infrastructure and raw survival collide every single day. If you drive eastward from the Mediterranean coast, you eventually hit a physical barrier that dominates the entire landscape. Most people simply call it a wall or a security fence, but those words completely fail to capture the sheer engineering reality of this massive structure. We are looking at a 440-mile-long, multi-layered military blockade. In the heavily populated urban areas, it is constructed of solid, reinforced concrete slabs towering 25 feet into the air. Each of these massive slabs weighs several tons and had to be transported and locked into place by heavy-duty construction cranes, often under direct hostile fire. They are rooted deep into the earth to prevent explosive breaching from below. But the massive concrete walls only make up a fraction of the total system. In the open desert and rural agricultural regions, the barrier transitions into a complex military corridor. This involves deep anti-vehicle trenches specifically dug to stop suicide car bombers from rushing the border. These trenches are flanked by layered razor wire and electrified fencing. It is not just a fence, it is a multi-billion-dollar sensor grid. Hidden beneath the dirt are highly sensitive seismic detectors designed to pick up the micro vibrations of anyone attempting to dig a tunnel underneath. High above, on heavy steel masts, thermal imaging cameras and autonomous radar systems constantly sweep the perimeter, feeding live data back to military control rooms. If a wild boar brushes against the outer wire, the system knows. If a human touches it, a heavily armed rapid response unit is dispatched to that exact coordinate within a matter of minutes. But building a wall this massive creates a staggering logistical nightmare. How do you maintain an impenetrable security perimeter while simultaneously allowing a massive essential workforce to pass through every single morning? The hard economic reality is that the Israeli construction and agricultural industries heavily rely on Palestinian labor. Every single day, over 100,000 workers need to cross this heavily fortified border. To handle this immense flow of human traffic, engineers had to design massive industrial crossing terminals. The most heavily trafficked is known as Checkpoint 300, located right outside the ancient city of Bethlehem. If you arrive there at 4 in the morning, you will not see a simple guard booth checking paper passports. You will witness an automated industrial assembly line designed to process human beings at maximum efficiency. The workers are funneled through a harsh maze of heavy steel turnstiles and thick concrete corridors. The security process is almost entirely driven by cutting-edge biometric technology. To cross the border, a worker must step up to a machine and place their hand on a specialized scanner. The computer instantly reads the unique physical geometry of their hand, mapping the exact length and width of their fingers, and comparing it to a massive centralized intelligence database. Facial recognition cameras simultaneously scan their features, cross-referencing their identity against military and police watch lists in a fraction of a second. The computer system instantly decides who gets to go to work and who gets turned back. It is a brutal and grueling daily commute. Grown men stand tightly packed, shoulder to shoulder, in narrow steel cages for hours before the sun even comes up, just waiting for a high-tech algorithm to grant them access to a job site in Jerusalem. The sheer mechanical throughput required to safely process 100,000 people through a hostile military border. Every single day is an engineering marvel, but it is also a grim reality. It completely blurs the line between advanced civil infrastructure and military occupation. You have billion-dollar technology firms designing biometric security software specifically to operate alongside razor wire and concrete blast walls. It is a harsh, unyielding physical barrier that permanently dictates the daily economic survival of every single person living in its shadow. I sat down at a small outdoor table in the ancient port of Jaffa and ordered a local Gold Star beer. When the bill arrived, I paid $15 for a single pint. That is not a tourist trap markup. That is the standard economic reality of living in one of the most expensive cities on the planet. Tel Aviv regularly outpaces New York City, London, and Singapore for the basic cost of daily living. But you have to look at the hard math to understand why a simple beer costs so much. It fundamentally comes down to commercial real estate and a massive national defense budget. When a nation has to spend billions of dollars every single year just to keep interceptor missiles in the sky, that capital has to be generated internally. The citizens and businesses pay for it through staggering consumption taxes, a heavy 17% value-added tax, and aggressive import duties on almost every single item that crosses the border. The overhead costs for a restaurant owner are astronomical before they even turn on the lights. This intense economic pressure and strict regulation extends directly into the basic food supply chain. Look at a global corporate giant like McDonald's. When they set up operations here, they had to completely tear up their standardized international business model. If you walk into a kosher fast food franchise in this country, you absolutely cannot order a standard double cheeseburger. Under strict religious dietary laws, mixing meat and dairy in the same meal, or even preparing them on the same equipment, is completely forbidden. The commercial kitchens must be meticulously divided with separate grills, separate fryers, and separate utensils. But the economic complexity goes far beyond just removing a slice of cheese from a sandwich. Look at the raw logistics of sourcing the beef itself. This is a nation where roughly 60% of the landmass is a harsh, unyielding desert. They do not have the massive, sprawling green pastures of Texas or the American Midwest to cheaply graze millions of cattle. Raising livestock in an arid climate requires importing thousands of tons of expensive agricultural grain and pumping expensive desalinated ocean water just to keep the commercial herds alive. Once the cattle are fully raised, the processing phase is even more complex and expensive. You cannot simply use standard automated industrial slaughterhouses. To meet strict kosher certifications, every single animal must be individually processed by a highly trained religious specialist. The meat must be meticulously inspected for internal flaws, drained of all blood, and heavily salted under constant supervision. Every single step in this highly regulated supply chain adds a massive layer of overhead cost. By the time that ground beef reaches a fast food grill, it has transitioned from a cheap staple to a premium engineered commodity. The global corporations are forced to adjust to a market where the standard rules of mass production are constantly interrupted by ancient religious laws and harsh geographical realities. When you buy a burger or drink a beer on this coast, you are not just paying for the raw ingredients. You are directly subsidizing the immense logistical machinery required to maintain a modern high-tech economy in the middle of a barren desert. Look at a satellite map of this region. More than half of the entire landmass is the Negev Desert. It is essentially baked, cracked dirt and rock, where temperatures regularly push past 100 degrees. Under normal agricultural rules, you cannot grow a single thing here. But survival dictates that you cannot rely on importing all of your basic food supplies from across the ocean. The engineers here had to completely rewrite the physical mechanics of farming. They did not wait for the weather to change, and they did not pray for rain. They invented a way to mathematically control the exact distribution of every single drop of water. The technology is called drip irrigation, and it was pioneered right here by a company called Netafim back in the 1960s. In the American Midwest, farmers use massive diesel-powered center pivot sprinklers that shoot thousands of gallons of water high into the air across massive green fields. In a desert environment, spraying water into the hot air is financial suicide because most of it evaporates before it ever hits the soil. Netafim engineers designed heavy-duty polymer pipes that run directly along the ground. Inside these pipes are highly complex microscopic mechanical emitters. They do not spray. They release water slowly drop by single drop directly into the root zone of the specific plant. The precision is absolute. My team analyzed the water data for commercial tomato farms operating deep in the harsh Negev desert. They do not measure their water usage by the acre like traditional farmers. They measure it by the individual plant. A single tomato plant in this brutal environment receives exactly 1.5 liters of water per day. Not a drop more and not a drop less. Liquid fertilizer is mixed directly into this closed system at the main pumping station. The computer monitors the soil moisture using underground sensors and automatically adjusts the flow rate without any human intervention. It is essentially an intravenous medical drip line repurposed for heavy agriculture. By stripping away all the waste, they are producing massive commercial crop yields straight out of dead sand. But you still need a massive source of fresh water to feed those plastic pipes. For decades, the country was locked in a constant drought, drawing down their natural underground aquifers to highly dangerous levels. The solution was to look west toward the Mediterranean Sea and build the Sorek desalination plant. This is not a standard municipal water treatment facility. It is a massive heavy industrial complex built directly on the coastline. It uses a mechanical process called reverse osmosis on a scale that is difficult to comprehend. Massive intake pipes suck in millions of gallons of heavy salt water from the sea every single hour. High-pressure industrial pumps then force this highly corrosive salt water through thousands of tightly packed microscopic polymer membranes. The pressure required to push salt water through a physical filter until only pure fresh water comes out on the other side is immense. We are talking about operating pressures exceeding 1,000 pounds per square inch. It requires a staggering amount of electrical power just to keep the turbine engines running. but the output completely changes the economic reality of the entire region. The Sorek plant alone produces over 150 million cubic meters of pure potable water every single year. That single facility generates a full 20% of the daily municipal drinking water for the entire nation. They took a dry desert nation that was literally running out of water and engineered it into a global agricultural powerhouse. Today, they actually have a surplus of water and sell it across the border. When you look at the heavy-duty plastic pipes snaking through the hot sand and the massive concrete walls of the desalination plants on the coast, you realize the hard truth. They did not turn the desert green through a natural environmental miracle. They forced the desert to yield crops through brute force industrial engineering, calculated fluid dynamics, and sheer human stubbornness. If you look at a map of the West Bank, it does not look like a standard country. It looks like a shattered piece of glass. Following the political agreements in the 1990s, the land was sliced into a highly complex logistical grid known as Area A, Area B, and Area C. For a military planner or a commercial supply chain manager, this map is an absolute nightmare. Area A is fully controlled by the Palestinian Authority. Area B is a mixed jurisdiction, but Area C, which makes up roughly 60% of the territory, is under full Israeli military and civil control. If you are a truck driver hauling heavy construction materials out of Ramallah, you cannot just drive in a straight line. You are constantly crossing invisible borders, transitioning between completely different legal systems, and passing through heavily armed military checkpoints, all within a 10-mile radius. Every mile you drive, your cargo might be subject to a different set of security protocols and commercial taxes. Yet right in the middle of this bureaucratic gridlock, an astonishing piece of civil engineering is rising out of the dirt. It is called Rawabi. This is the very first planned city in Palestinian history. It is not a temporary camp, and it is not an ancient village. It is a $1 billion high-tech metropolis carved directly into a steep hillside, entirely bankrolled by massive Qatari investment funds. The construction process was brutal. Engineers had to use heavy explosives to blast millions of tons of solid rock out of the mountain. They had to build their own rock-crushing plant right on the site because importing basic gravel through the military checkpoints was financially and mathematically impossible. When you look at the master blueprints of Rawabi, it looks exactly like a high-end American suburb. They laid down massive underground fiber optic cables, built a centralized commercial district, and constructed an open-air amphitheater capable of holding 15,000 people. But building a billion-dollar city in a conflict zone requires more than just pouring concrete. The developers faced staggering logistical walls. To get the basic materials onto the job site, they had to negotiate for years just to pave a narrow 2-lane access road through Area C. Then came the water. A city of 40,000 projected residents needs a massive and reliable water supply. Because the underground aquifers are strictly regulated, the developers had to engage in brutal high-stakes political negotiations just to get a single water pipe connected to the Israeli national grid. They built the shiny high-rise apartments, but for months they sat completely empty because there was no water pressure to flush the toilets. It is a prime example of how ambitious civil engineering constantly collides with heavy military bureaucracy. And then you have the hard economic reality on the ground. Ramallah is the bustling financial capital of the West Bank. It is packed with corporate headquarters and luxury car dealerships. But if you walk into a coffee shop or buy a piece of commercial real estate in Ramallah, you do not pay with a local Palestinian currency. The entire economic engine runs on the Israeli shekel. It is a bizarre dual economy. You have a population working under one political authority, but the paper money in their wallets, the inflation rates they suffer, and the interest on their mortgages are entirely dictated by the central bank of the nation, sitting on the other side of the concrete wall. Because the Palestinian Authority does not have its own central bank, physical cash management is a massive logistical headache. Armored trucks carrying pallets of paper shekels must constantly navigate the military checkpoints just to balance the bank vaults in Ramallah. It is an intricate web of money, concrete, and survival, where the physical borders are heavily armed, but the flow of hard currency never completely stops. Let us talk about the sky over Tel Aviv. When a siren sounds, you do not have minutes to react. You have seconds. Depending on where you are standing, you might have as few as 15 seconds to find a reinforced concrete shelter. What happens next above your head is not magic. It is raw, unyielding mathematics, and one of the most complex engineering feats on the planet. It starts on the ground with a massive piece of hardware called the ELM-2084 radar system. This is not the spinning dish radar you see at a commercial airport. This is an active, electronically scanned array. It is constantly staring at the horizon, processing massive amounts of data in real time. When a blip appears on the screen, the system has exactly 2 seconds to make a life or death decision. In those 2 seconds, the algorithm must determine if that object is a flock of migrating birds, a passing drone, or a Soviet-era Grad rocket loaded with high explosives. The computer analyzes the speed, the trajectory, and the radar cross-section. But it does not just track the object. It calculates exactly where that piece of metal will land down to the specific city block. If the rocket is heading for an empty desert patch or the open sea, the system stands down. It lets it fall. But if the trajectory points to an apartment building, a power plant, or a busy highway, the computer instantly triggers the firing sequence. Enter the Tamir interceptor missile. This is where the physics get brutal. When the Tamir launches, it is experiencing immense G-forces, accelerating to over Mach 2 in the blink of an eye. Data is constantly being beamed from the ground radar to the missile, updating the target location in mid-air. But the Tamir does not fly up to simply ram the incoming rocket. Hitting a bullet with a bullet head-on is statistically unreliable. Instead, the missile relies on a highly advanced proximity fuse. It uses onboard electro-optical sensors and steering fins to maneuver itself right alongside the incoming threat. When it gets within a few feet of the target, it intentionally detonates its own warhead. It creates a high-velocity wall of tungsten shrapnel in the sky, perfectly timed to shred the incoming rocket and trigger its explosive payload before it ever reaches the ground. You see the bright flash in the sky, but what you do not see are the thousands of micro-adjustments made by those sensors in the final milliseconds. But here is the part that makes military logisticians sweat: the brutal math of defense. The rockets being fired over the wall are often crude, unguided weapons. They are welded together in underground workshops using repurposed water pipes, smuggled fertilizer, and scrap metal. A single enemy rocket might cost $500 to build. $500. Meanwhile, every single Tamir interceptor missile fired by the Iron Dome costs approximately $50,000. When a sudden barrage of 20 rockets comes over the border, Israel is spending $1 million in a matter of seconds just to neutralize $10,000 worth of welded pipes. On paper, it sounds like a rapidly losing economic equation, but you have to look at the true cost of impact. What is the financial cost of a destroyed hospital? What is the cost of repairing a collapsed highway interchange? What is the cost of a panicked workforce staying home and shutting down the national economy for a week? The Iron Dome is an insurance policy. It does not just protect concrete and steel. It prevents the entire country from grinding to a halt. I have seen the footage. We have all seen the videos of these intercepts lighting up the night sky like fireworks. It is a visual spectacle, but the telemetry behind the intercept is where the real war is won. It is a high-stakes game of physics and economics played out at 2,000 miles per hour, where the machinery simply cannot afford to fail. Look past the physical borders and the concrete blast walls for a moment. The most dangerous threat to the long-term stability of this nation is not an incoming missile or a hostile foreign army. It is a slow, ticking demographic time bomb entirely contained within its own borders. You have a massive and growing ideological divide between the secular high-tech tax-paying citizens living in Tel Aviv and the ultra-Orthodox or Haredi communities concentrated in Jerusalem and Bnei Brak. The raw mathematical data here is inescapable. The Haredi community has a staggeringly high birth rate, averaging nearly 7 children per woman, compared to the secular average of just over 2. By the year 2050, demographic projections show that roughly 1/3 of the entire national population will be ultra-Orthodox. But this is not just a cultural difference. It is a brutal and immediate economic friction point. A massive percentage of adult Haredi men do not participate in the modern secular workforce. Instead, they dedicate their entire adult lives to studying ancient religious texts in specialized academies, which are heavily funded by government subsidies. That means the immense financial burden of maintaining a high-tech military defending the borders and running a modern civil infrastructure falls squarely on the shoulders of the secular working class. When my team spoke with local business owners and software engineers, their frustration was absolute. They are paying a massive income tax rate to directly subsidize a rapidly expanding community that largely refuses to participate in the global economy. It is an economic equation that simply cannot sustain itself over the next 2 decades. And then you hit the absolute core of the current political crisis: the military draft. In a country completely surrounded by hostile forces, military service at age 18 is mandatory for survival. Secular 18-year-olds are sent to the front lines to drive heavy tanks, patrol hostile borders, and operate the Iron Dome. But since the founding of the state, the ultra-Orthodox have been granted sweeping legal exemptions from military service to continue their religious studies. For decades, this was quietly tolerated because the Haredi population was relatively small. But today, with their numbers exploding, the secular families are demanding that the brutal physical burden of national survival be shared equally. This single issue has triggered massive street protests and completely paralyzed the central government. You have a society capable of shooting down supersonic rockets and building billion-dollar tech companies, but they are currently being ripped apart from the inside by an unresolved crisis of faith taxes and military duty. People sitting in comfortable armchairs across the ocean love to talk about simple solutions. Politicians draw clean lines on paper maps and talk about peace treaties as if this is a standard real estate dispute. But when you are standing on the ground looking at the massive concrete walls, the underground tunnel networks, and the overlapping security grids, you realize a brutal truth. There is no simple solution here. You cannot just pack up and untangle a society that is this deeply intertwined. The water pipes the electrical lines, and the physical survival of millions of people are locked together in a complex mechanical knot. This is not a brief conflict. It is a 100-year war of attrition fought simultaneously with ancient religious texts and supersonic interceptor missiles. But there is a massive misconception about what is actually at stake here. The world looks at this conflict and sees a tragic, never-ending battle over a tiny strip of arid desert. That is entirely missing the bigger picture. This is not just about land anymore. It is about the absolute future of Western technology and global security. This small nation has become the ultimate live-fire testing ground for the defense systems that will eventually protect the rest of the modern world. The biometric border scanners, the automated drone interception algorithms, and the deep cyber warfare codes being perfected in this desert right now are the exact same tools that will be deployed to protect American infrastructure, European financial institutions, and global shipping lanes in the coming decades. What happens in this microscopic piece of the Middle East dictates the future of global military logistics. The engineers and soldiers here are writing the survival manual for the next century of warfare. They are proving what happens when a society is forced to innovate every single day simply to prevent themselves from being wiped off the map. It is a harsh, unyielding environment that produces some of the most brilliant and dangerous technological advancements in human history. You do not have to agree with the politics to respect the sheer mechanical resilience required to keep the lights on and the borders secure. The human drive to engineer survival out of a hostile landscape is a universal language,